Now we are going to see some programming based on whatever loops that we have studied. And out of that, the first thing we start with, which we have already seen, is to find a even number and odd number. Now I will the program for you. So basically, a number that is exactly divisible by 2 is called even number, and which is not divisible by 2 is called odd number. So the program will start with inclusion of libraries, then declaration of int main function, declaration of a variable int num. Now we haven't assigned any value to this num, so it can take any random value at the declaration. Then we ask user to enter an integer. We do a %d and then use a ampersand and take the reading of num. So if user enters 7, then that 7 will enter. So that 7 will be stored in this variable num. Next thing is if num modulo operator 2 is equal to 0, then that number is divisible by 2. So if that number comes out to be 0, then we have to print that percent d number is even. Now what is this percent d? Is fill in the blank. So there we will put the value. So in this case, since we have entered 7, this condition won't be true. So if will false, it will go to else. Now inside else, what we have written printf %d, again a placeholder is odd, and then placeholder is filled with num. So it will display as 7 is odd. So here is an example. Enter integer. User has entered -7 and it is displaying -7 is odd. Now, in the program, integer entered, it's stored into the variable num, and whenever num is perfectly divisible by 2 or not, it is checked by the operator modulus. So here, what we have seen is if loop and the modulus operator used. Next program we are going to study is if the, okay, so in the same program, if the number is perfectly divisible by 2, then this expression number %2. So now we have used the variable num, so this should be num %2 is equal to 0. And if this condition evaluates to 1, that is actual division is 0, but then this condition is true, that number is 0. And that's why this condition is evaluated to 1, and that means it's true, and this means the number is even. However, this expression is failed to evaluate, then answer is 0, and that's why the number will be odd. Now next is write a program to check odd or even number using a ternary operator. So it's the same program, but this time we are going to use a ternary operator. So first line is include stdio.h, which is a library inclusion. Then int main, which is where we are including the main function. This line is mandatory for any C program, so you can't avoid. You can just write instead of int, you can write void main, but without main function, none of the C program will execute. So main function is mandatory in C programming. Then comes the int num. Now here you again declare a num. You ask for a value of that number from the user. So this part is pretty common. Printf will display the result to the screen. Scanf will take a input from the screen, whatever user is entering. And if you make some weird entry, this %d will try to evaluate the nearest value. Let's say some user enters a and it was asking for an integer. So it will actually do its ASCII conversion and you will have a random number stored at num. Then now this is a different thing. Instead of letting if, you give your condition first. Okay, ternary operator takes the condition. What is the condition? If num %2 modulo operator is equal to 0, then is this question mark. Then printf %d is even num is the answer. So this is the single statement if you want to do inside a if. This is how you do it, and this is the else statement. So remember, inside equivalent of if and else statement, but this you can only do, or ternary operator is only used preferred when you have only one statement for if and else. and then you return 0. So if this statement is true, then this particular output is executed. If statement is false, then after colon, whatever is there, that part will get executed and this part will not. So output, enter an integer, user entered 33 and it showed 33 is out. In the above program, we have used something called as ternary operator. So this combination is called ternary operator instead of if else. Now, uh, next program, I think I missed out something. Okay, anyways. So next program is write a program to check the vowel or constants. Now there are 5 letters A, E, I, O, U, which are called vowels, and all the other alphabets other than these 5 are called constant. Now consonants. Basically, this program will assume that user will only enter an alphabet character. Okay. So let's start with the program. To check whether user has entered A, E, I, O, U, or maybe some number, some other character like M, N, P, etc. So let's see how this program is to be written. So first thing, you have to include the standard library stdio.h, then your int function. So there is no change. As per our declaration, we include 4 libraries: stdio.h, then standard lib.h, then conio.h, and then mat.h. Then we declare char c, which is the character type declaration, and again the variable name is c. You can write char d, char x, whatever variable name you like. Then int, there are 2 integers involved here: lowercase vowel, uppercase vowel. So there are two we say temporary operators. We will see why these are required in the further part of the program. Now we ask user to enter an alphabet, and we use this time no percent %c, it's percent %d. It's percent %c for the character entry and ampersand a. So remember, in the exam, people will forget this ampersand, and instead of their entire code being correct, they make a mistake on the ampersand. So don't forget to put percent, and sometimes you put percent %d and you still write ampersand %c. So these kind of mistakes will happen from student. I'm sure about it, and you will be one of them. Next is evaluate to 1 if variable c is a lowercase. So lowercase vowel is equal to. Now we are directly asking what is the value of c. Okay. If c is equal to a, or c is equal to e, or c is equal to I, or c is equal to o, or so any of these. Now you will ask me why not continue with all 10 putting this or sign, and then you can write c is equal to capital A. Also fine. There was no need to take 2 variables, lowercase and uppercase. You could have written all the 10 together also, but it's very easy to find whether it was a lowercase or a uppercase. So that's why we are just putting it. I remember, again and again I'm telling you, there is no fixed solution to given problem. You can have at least 400 solutions, 400 different statements doing the same thing in the program, and that's why no one is wrong in this programming. No one is right. Basically, how efficient your programming is all that matters. Okay. So don't worry if you write it in a different way. Don't keep on asking me whether it is correct or not. It is correct if it is doing what it's supposed to do. Okay. And you might have hundreds of ways to do it. Which one is more efficient, that we have to understand. Now, sometimes when your teacher teaches one kind of solution, student always remember that kind of solution. So that's why we are teaching you some of the standard solutions, which may not be the perfect. You might have even further optimized the solution, but keep it to you. Next is evaluate the true and false. So now we are just checking whether lowercase is 1 or uppercase is 1. So this double straight line means or. So if I say A is better, or B is better, or A and B is better, any of these statement is true, output is gonna true. So this or basically 2 straight lines is what we say any of. So A or B, like I need a company. So even Rahul can join me or Sachin can join me. So it's like or. But anyone joins, it's a or. So if both join, still I have a company. If only Rahul joins, I have a company. If only Sachin joins, I have a company. Then if if any of these is true, then I will say %C, that is whatever entered vowel is there, comma C, and then else if it is consonant, then I will just put the %C again. This %C, remember, is for the fill in the blank. So %D, %C inside a printf statement means it's a fill in the blank. Now you have to think, if I want to display percentage like 15% I got, how we will do it. Okay, we have learned the escape character for that. You have to use those. Now return 0 and then closing bracket. So these two statements are again kind of permanent in any C program. Then enter alphabet. User has entered a G, which does not belong to A, E, I, O, U, and that's why it's a consonant. Let's see how this particular program works. The character entered by the user is stored into the variable C. The lowercase variable equals to true if C is lowercase vowel, and if it is 0 only for any other character. Even A, E, I, O, U is capital, the lowercase vowel will give 0 result. Similarly, the uppercase variable will be evaluated to true if C has a uppercase vowel and 0 for any other case. Now, if either of the two, that is lowercase or uppercase variable is true. Now, in exam, students do write the code and they just write lowercase. They have this tendency of making a mistake. They only write a code for lowercase and they say, we are done. Our program is ready and now you can check. So sometimes you have to think beyond the limits that if you are thinking that user can enter a capital AEIOU, still it's a vowel and still your program should work. So you have to think of all possible inputs that user can enter. And then once you know about those inputs, then only you can think of correct way of programming it. So there are multiple ways in user will do. So this is where typically a system is iterated. So generally we deploy a system and then we realize that user is entering something different. Then we do a remodification. That is what we call it a software tester or a hardware tester job. When we deploy the system, we think it is correct, but at the same time, user, when it uses, it gives us something else. And then we have to correct the system. So there are some stages once you deploy. We call it iterations, and then it goes ahead. So however, if both the variables, so in this case, either it can be lowercase vowel or it can be uppercase. You will not see both the numbers to be 1 1, but both the numbers can be 0. Like if I enter n for Ninar, that means it's not a smaller case AEIOU, it's not a capital case AEIOU. So both will be 0 and then it will display the consonant. So this program assume that user will enter an alphabet. Now, if user enters a non-alphabetic character, it displays the character is consonant, but which is not correct. So to fix this, we can use a command which is called isAlpha function. Now, isAlpha function whether checks that alphabet entered is alphabet or not. So if you write this isAlpha inside if and then you display the consonant, that will be great. So this is how you can correct the problem. Now, most of us will not believe that somebody has entered colon to this program, but user does like that. So we have to be prepared for all possible kind of cases. Next program, it's a similar implementation what we have studied, but this time let's see what is the different. First thing is we will check whether it's a alphabet or not, and then we will execute the other program. So here it's the isAlpha is a library function of C type.h. So in case you need isAlpha function, don't forget to include C type.h, then stdio.h. Then we have our 4 standard library execution. Then int function, which is the main function, character C. Again, similar program. So lowercase, uppercase are declared. User is asked for an alphabet and that is stored into the C. Then we are actually checking whether that C is one of these two, that is capital AEIOU or small AEIOU. Now you can say this checking can be done later also. It's okay. Again, I am telling you each program will have multiple solutions and you don't have to argue that why you are doing it before and why you are doing it later. It's as long as it is doing its job, it's okay. Now next is, now we will check whether the character is an alphabet or not, and then we pass the character, which is C in this case, to this is alpha function. Now is alpha function will be true if that C has a valid alphabet, that is one of the 52 alphabet. No, then it will throw an error saying that it's a non-alphabetic character. Now, else if lowercase vowel or uppercase vowel, so remaining part of the program is same. That is when it is vowel and when it is consonant. So if user enters a non-alphabetic character, you will see if user enters 3, then it will show a non-alphabetic character rather than saying it's a consonant. So that is a better program or improved program compared to the earlier one, provided we know this function that is alphabet works. And you can see that exclamation mark is given to inverse the 1 or 0. So if is alpha goes true, then we don't want to do anything. Okay, so that's why a not get is given. So whenever this sign, you will see this is a function of not, a logical output will be inverted. So when I say 1, maybe my student will say 0, and when I say 0, my student will say 1. So the not get always reverses the actual answer, and it is used very frequently in the C programming to fluctuate, or you want to put the condition which is in if, that can be put in else. So if A, and in else if B, as soon as you use not, then your B becomes if statement and A becomes else statement. So remember, the not function is used if you want to put a iterative loop, and if you want to swap the contents of if loop and else loop with each other. Now another example using if statements, like this program we have already studied as our experiment 2, where to find we are asked to find the largest of the three numbers. So this is with the if statement. So user takes three inputs in the double format, n1, n2, n3, and it will ask the user to put enter three different numbers. Now since it's a double, we call %lf, 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 and then ampersand n1, ampersand n2, ampersand n3. Now remember, whenever you see these programs onto the screen in this PowerPoint format, you will think that it's very easy to do programming in C, as long as I am showing you the code and not asking you to just understand the code and I am explaining. But as soon as you decide to write one on your own, then suddenly this simple program will become tough for you. So remember, it is not good practice to read the codes or listen to the lectures of the C programming. It's always best that you do this coding, and once you do this coding, then you can check the solution if you got stuck anywhere. So always practice for C programming. If you don't practice the C programming, it's very difficult for you. And as a computer engineer, we should always have a habit of writing our own codes than using somebody's referred codes and then just modifying. That is a very bad practice for a computer engineer. So from day one, I'm telling you, just write your own code. If it doesn't work, that's great. If you get an error, that's even better, because then everybody will understand that when this kind of error happens, what could be the mistake that user might have done. So let's understand how the three numbers are compared. If n1 is greater than n2 and n1 is greater than n3, then we are just displaying the two-digit value. So that's why 0.2. So after decimal point, if you enter 10.1375 and then you write percent 0.2f, this will only truncate the values, just neglect the other values, and then it will just display 10.13. So remember, if you want to have accuracy up to two decimal places after the decimal point, then you write 0.2f. Okay. Let's go ahead. Now we will check if n2 is greater than n1 and n2 is greater than n3, then largest number is n2. Similarly, n3 greater than n1 and n3 greater than n2, largest number is n3. Now even you could have write else over here, because this condition was false, this condition was false. So it's obvious that n3 will be largest, and you could have just displayed it. but it's okay because it's just if statements. It's not nested or the uh, regular if statement, that is ladder if statements. It's just if, no else. So this is how you implement the comparison of three numbers. Now let's understand how to implement the same program using if else ladder. So let's start with the code. First thing is include stdio.h. So that will include the standard libraries. Next thing is int main, and then you double the three characters. Somebody is unmuted himself. Please mute yourself. Next thing is once user enters the three numbers, then you scan those three numbers using %lf and then write n1, n2, n3. So this part of the program is still same. If the first statement is also same, where we compare n1 with n2 and n3 using and. Now when I put and, then I say I want both of the statements to be true. So remember this, if you don't use double ampersand in C program, that means your statement A and statement B has to be true to have a valid truth or a true output at the finally if loop. So there is a difference between or means A or B can be true, and means A and B both has to be true. Now similarly else if. So now it's a ladder. So after every if there is else if, and once we end with the ladder, you have to put finally the else statement. So you can have infinite number of else if connected together. Right now we need only one else if in the ladder. So first if starts, then n2 is greater than n1 and n2 is greater than n3. That is also compared and displayed the number as n2 as largest. Else, because we have already checked first two conditions, we can definitely say that n3 is true. And this is what we called reverse proof, or you try to do some assumption, do some hypothesis and prove that hypothesis is wrong. Similarly, when n1 is not largest, n2 is not largest, then by default n3 will be largest. Now, this condition might fail somewhere. We have to think in critical way, but this will fail if we have some one of these two as equal, like n1 equal to n2 and n2 equal to n3 and so on. So if you just want to display the largest number, this program is fine. But if you are asked to find which one is largest, and if any of those two is largest, it will always end up in a by default condition of else loop. So next is let's see how the same program can be used using nested if instead of ladder. So in this case, first thing is I will check if n1 is greater than n2. Okay. And inside that I will check if n1 is greater than n3, then n1 is largest. If not, I obviously know that n1 was greater than n2, and at the same time I also know now n3 is greater than n1, and that's why n3 will be the largest. Okay. Else means I already know that n2 is greater than n1, and now I just check if n2 is greater than n3 also, then I will print n3 as largest, else I will print n3 as the largest number. So this is how the nested if will look like. Then output of the same program will be if user enters minus 4.5, 3.9 and 5.6. Obviously the largest number will be shown as 5.6. Now remember, minus 4.5 is even less than 0. So anything with negative sign is less than 0, and higher the number value is like minus 5.5 is even lesser than minus 4.5. So this is how the C program sees. Next is if you want to find out the root of the equation a square plus bx plus c, and where a, b, c are the three numbers. So we want to find out the solution of a quadratic equation. So the term b square minus 4ac is also known as discriminant or quadratic equation, that tells the nature of the root. If the discriminant is greater than 0, then the roots are real and different. If the discriminant is equal to 0, then the roots are real and equal. And if the discriminant is less than 0, then the roots are complex and different. So remember these three conditions. Okay. Now there is nothing called as complex and equal. We will see why. But basically, first we have to calculate the discriminant. Once we know the discriminant, we have to use the loop, and then as per the correct solution, we can say these are the formulas for the root. Now this is all maths. So in case if you don't know how to find the um, solution for a quadratic equation, you can refer to this table. In exam, they might expect that you know this because in maths also you are studying this. But in case you don't know, it's okay. You can solve it manually also. So first thing is, if your discriminator, that is b square minus 4ac, is greater than 0, then your solution 1, that is root 1, will be minus b plus under root b square minus 4ac bracket close upon 2a. Similarly, root 2 will be minus b. Now here we will introduce a new term for your square root called sqrt function, and that's why this kind of programming is must. Similarly, if discriminant comes out to be 0, then the solution is pretty straightforward. Root 2 equal to root 1 equal to minus b upon 2a. And if it is less than 0, then you can see that the sign of this intermediate stage, okay, that is basically different. So here you are dividing the entire term, but this time you have to put a I in between, and then you have to use the same formula. So it's under root b square minus 4ac, which is your discriminant term, upon 2a, that you have to separate because you are multiplying it with a complex number I. Now, those who don't remember anything about this I guess this I, or sometimes it is also referred as j, which is also known as under root of minus 1. And this will come with a complex number system. So there are numbers like 3 plus 5j or 3 plus 5i, how you write in the maths, I don't know. But typically these are the two representations of a complex number, where this part is called real part and this part is called imaginary part. Now we will not go into the mathematics, but this program we have to write. Now find the root of a quadratic equation. So this is the code. Let's try and understand how this particular code is written. So a special function is required in this. So that's why we are including mat.h. So here we will start declaring double ABC discriminant, and then root 1, root 2, which is the solution, and real part and imaginary part in case the solution is complex. Now printf, enter the three coefficient. So user will enter, so ax square plus bx plus c. This is the nature of the equation, equal to 0. So we ask user to enter the value of a, we ask user to enter the value of b, and we ask user to enter the value of c. So all these three types, don't forget, always take double or even float will work, but always go for a double or float, not an integer values. Otherwise, you will mess up this entire coding. Then you scan all these three numbers. Next is we will find out the discriminant, that is b square minus 4ac. Now here we have used a simple logic that b into b is b square. So that's why this particular into sign, and then we square it. Now condition for real and different roots. The first case, if discriminant is greater than 0, then root 1 is the first formula. Here you can see square root, and then we don't recalculate the same thing. We have already computed b square minus 4ac. So we can directly substitute here, divide by 2a, because the whole term is getting divided by 2a. A bracket outside will work. Similarly, root 1 only changes plus to minus, rest of the formula will remain same. Now then you print root 1 %2, that is up to 2 decimal places accuracy, and root 2 again 0.2 lf, and root 1 and root 2 are displayed. Now conditions for real and equal root. So if discriminant is equal to 0, although these both terms will get cancelled because discriminant itself is 0, and your final answer is minus b upon 2a. So root 1 equal to root 2 is equal to percentage lf, and you just calculate only one root and that you display. Now in the third case, when the roots are not real, then you have to calculate real part separately, which is this formula, and then you have to calculate the imaginary part separately, and then you write in this format. Okay, otherwise you will get an error. So first you write the real part, then percentage, type I or your imaginary number, and then again percent point two f. So this is how you display real part, imaginary part, real part, imaginary part. Now again, the values will be complex conjugates, so you don't have to calculate multiple times. Only one time calculation of real part and imaginary part would be good enough. Once you have to write plus ij, and next time you write minus ij. So the output here, user has entered 2.3, 4 and 5.6, and the correct root is minus 0.87 plus 1.3i, and root 2 is minus 0.87 minus 1.3i. In this program, square root library function is used to calculate the square root of a number. Now, a leap year program. So leap year program is a program which is divided by the 4. So whenever you are asked to write a program which can determine whether the entered year is leap or not, you can refer to this particular program. So here, the years ending with 00 are also leap year. Then the century year is also a leap year. And if it is perfectly divisible by 400, then also it's a sorry, these are the non-leap years. So all the numbers which are getting divided by 4 are straightforward leap years. Only case is if the year is ending with 00 or the century is ending, the century year is a leap year, and it is perfectly divisible by 400. So for example, 1999 is not divided by 4, so it's not a leap year. 2000 is a leap year, 2004 is a leap year. So let's try and understand how to write this particular leap year program. Again, user will enter a year like 1953, and you will display to him whether it's a leap year or not. First thing is we will check whether it's perfectly divisible by 400. If yes, we will display it's a leap year. I think I said it wrongly last time while explaining. So if it is divisible by 400, it's a leap year. Next, if it is divisible by 100, so that is a decade year, then it's a not leap year. So first you check for 400. If it is completely divisible, if the answer comes out to be 0, just display it by leap year. But if it is not divisible by 400, but it is divisible by 100, then it's a non-leap year. Okay. So in case of 2000, yes, it was divisible by 100 as well as it was divisible by 400. So that's why it was a leap year. Maybe you guys will never see this, like 1900, is it divisible by 400? We have to check, but it is definitely divisible by 100. And maybe this particular number, now 19 by 4 is not divisible, so it will fall under this particular category. Now, if none of these conditions are satisfied, then it will directly check if that number is divisible by 4. So remember, the lowest priority is if it is divisible by 4 or not. Otherwise, first thing you have to check, the highest priority is divisible by 400. Then second highest priority is if it is not divisible by 400 but it is divisible by 100, then it's not a leap year. And finally, it's a straightforward. So in exam, I have seen many students directly go for this particular case without referring to these two because they don't have any idea of these two conditions at all. So they get a partial marks, but to achieve the full marks, you should remember that first you have to check if it is divisible by 400. If not, then you have to check whether it's a divisible by 100. Because 1900 was still divisible by 4, but still it is not a leap year. So that is a condition. And if none of these conditions get satisfied, you have your standard else condition, which says it's not a leap year. And see here, they have given the same example of 1900, which is not a leap year, and 2012 is a leap year. So next is we have to write a program whether the a number is positive and negative. We have already written this program, so it's very straightforward and simple code to write. So here there are three outcomes. So again, this third outcome generally student miss out. That is, it could be a positive, it could be a negative, or it could be a zero also. So user have to check whether the number is positive or negative using if else condition. Let's start the programming. It always starts with the inclusion of library, then int main double num. User will ask for to enter a number and you scan that number. Again, you will see most of the times throughout this programming, I have used double. Now, why double? Because it's the biggest size variable and I don't have any limitation on my variable. So I generally ask students to start with double. Don't keep limited to yourself like int or though the int is easier to operate, you will mostly land up into the problem with ints. There is no issues if you write 4 instead of in int, if you write 4.00, your program, since it is giving you correct answer, it doesn't matter. Internally, 4.00 and 4, it doesn't look good. If you want to limit your restricted display, you can write percent %1f or only one decimal place will get displayed. You can also try if you have %.0f works for you. And then you have to check. Now here again, don't check with the integer 0, directly check with 0.0. So when you are declaring something and you don't want to declare as an integer, just put a dot and then 0 after that dot. So let's say I want to define 13 as a double and not as an integer. So I can write a equal to 13.0 instead of just putting 13, because it might take C program assume this as a int and then it will throw an error that you are trying to compare a double variable with int variable. So just don't forget to put this dot 0. In exam, many times students make this particular mistake that they compare a equal to 13 instead of a equal to 13.0. So here, if it is 0, uh, then if it is firstly greater than 0, then we are going to say it's a positive number. Then we check whether it's a 0, you have entered 0. If not, then you say it's a negative number, because num less than 0.0 is the condition that we check. And if it is less, it's a negative. If not, then it's a positive. So anything, so remember, at 0, it's neither a positive nor a negative number. People just make a mistake of just comparing it with 0. So just check whether it is less than 0, it is definitely a negative number. But if it is more than 0, it is definitely a positive number. At 0, you have to say it's a 0. Now you can also solve the same problem using nested if else also. It looks like this. So in this program, we have stdr.h and main.h, which are the standard declaration, then a double, then enter a number, %scanf. So I am not just explaining because we have done a lot of time same kind of work. So only check the logic now. If num is greater than 0.00, you have entered, if num is less than 0.00, you have entered a negative number. If num is greater than 00, you have entered a positive number. And if if both conditions are failed, then it has to be a 0. So this is like assume statement, and that's why you can use directly else.
Sir,
Yes.
so this one is nested if, or the previous one was nested?
Yes, sir. The previous one was nested if, no?
Yes.
Uh, yeah, this is ladder. Sorry,
This is the
this one
ladder.
should be ladder because we are using else if. So whenever you see this kind of structure like if, then else if, again else if. So these are what we call the ladders, and this is how I visualize it. So whenever you see this kind of structure, then we call it a ladder program. And at the end, you might have else or you don't leave as it is. So this is a typically ladder is formed, and nested if is something like if inside if you find another if inside if you find another if. So if this condition is true and then it checks for this condition and then it checks for this condition, this is what we call a nested if loop. Now output 12.3 positive number 0 0. Next is write a program to check whether character is alphabet or not. Now again, this we have already seen there is a direct function for this, but now we are asked to write a program. So This program is eventually be put as a function into a C program. And that's why C program is a continuously developing language with more and more libraries being added. So remember, you don't have to reinvent the wheel and start your C programming from the beginning. I would always like that you use a ready-made function and make your code shorter, because those functions are already tested before they are included into your C programming package file. So in C programming, the character variable holds the ASCII value. Now for an integer number between 0 to 127 rather than its actual character value. So ASCII program is a lowercase alphabet, starts from 97 and it goes up to 122. I'm not sure, but you can check. A is equal to 97 if you write, and then B equal to 98. Hopefully, we will end up at Z equal to 128, because you keep on writing next digit. Total 26. Then uppercase letter starts from 65 and they go up to 90. And you have to check. I think it's 96, but you can check that whether it's correct or not. Then finally, the SK value range from 97 to 122. So some x1 to x2, we can check the actual value, and then some y1 to y2. So if your character ASCII character lies in this range, then it's a valid alphabet, or otherwise it is not. So a simple program to do this: first you declare your standard IO libraries, then you define your character. Now here you input read as a %c only, so your character will be stored as a ASCII value only. Now here, while comparing, remember you can directly compare a character with character. So if C is greater than equal to A and C is less than equal to Z, that means it lies between. This is basically 97 and this does means 127 for the C program. And then if C is greater than capital A and C is less than capital Z, less than equal to, don't forget to put equal to, because small a and C is also Z is also included. Um, so finally, you can say that C is alphabet or C is not an alphabet. And same thing is what this function is alpha does inside. So somebody has written this function and just put as a library. So inside the is alpha function dot C, if you open, you will find the same code. But instead of writing printf statement, they will return 0 or return 1. So output of a character, if you enter star, it will say is not a alphabet. Now in a program, A is used instead of 97 and Z is used instead of 122. Similarly, capital A instead of 65 and capital Z instead of 90. It is recommended to use is alpha function to check whether the character is alphabet or not. But still you can write your own code. Next is we have already written this program, so I will just run through, write a program to calculate sum of natural numbers till that particular point. So we will learn to calculate the sum of natural numbers entered by the user. So for example, if user enters positive 10, then it will start adding 1 plus 2 plus 3 plus 4 up to 10. Since it's a sum of natural numbers, natural number starts with 1 and not 0. So you will add those 1 plus 2 plus 3. So program is pretty straightforward. There are declarations of n, I and sum over here, and you equate it to 0. Then you ask user to enter a positive number. You scan that number with %d sign. Everything is integer. And now you start a for loop with 1, then go up to n and keep incrementing your I. And then you just write sum equal to plus I. So this statement sum, I personally like to write sum equal to sum plus I. It's very easy to understand also, and just avoids any kind of confusion. But some examiner will ask you to write the same program using this, so you can use this particular statement. As soon as you don't have any restriction to use this kind of variables, I would also suggest you guys to maintain this simple syntax formatting rather than writing a complex code, so that you only, most of the times the 99% of the code will be read by you only, because you have written the original code. They will ask you to correct it and not any third party. But in some cases, they might ask other person to read. So in both cases, writing this kind of syntax is always better than writing any other kind of syntax. Similarly, some of natural loop can be done using while loop also. So the first part is still the same. Now instead of for loop, we can just initiate I. So when you are using while, you have to initiate outside the while, before while. Then your condition goes inside while, and then your increment operator like inside while case check, and then increment operator is actually inside while. If you forget this statement, you will put your computer into a something called as infinity loop. It will get hanged and it will keep doing what it's doing. It doesn't give you any output. Now this is kind of virus in old cases, like bad programming was, they used to call it a virus. Now more or less those kind of viruses are vanished. But basically now whatever you say virus, we call everything like malware, phishingware, everything we call it as a virus, but they are not. They are purposefully designed programmed to steal your passwords, bank account information, and maybe some personal information also. So remember, the wares, those are malwares, phishing wares, etc., is not same as a bad programming. Actually, they are very skillful programming written by, and it's a like a gray area truth that all the antivirus companies use hackers. They hire the hackers to write a new virus so that their antivirus company can run. Otherwise, there is no one producing a virus for you. So it's kind of a business model. And but still, this kind of attackers are there, and we as a computer programmer should always try to avoid these kind of attacks. Now entered 100, and then till 100 all the natural number sum come out to be 50-50. In both the programs, the n is stored as a number of times, and then the iteration I is incremented by 1, and final answer is stored into a sum variable. Though both the programs are technically correct, it's better to use a for loop because its number of iterations is already known. The above program don't work correctly if user enters a negative number, because little modification in the above program, we can take next program as repeat until the positive integer is entered. So this program also we have done. Here you have to keep adding a number, and whatever number user enters till the positive number is entered. So this is how it will start stdio, then declare some variables which are n, I, and some. Remember, I for iteration. So most of the programmers have this habit of using I for iteration, some for your summation, and maybe n for your number. So that's why you will see most of my program also I use n as a variable number. If you need one more, you use m, n, p is the third variable, and then there are x, y, z. So these are some of the popular variable names. So most likely, if you see these variables, they are used for a storage of the variables. And if you see some variables like ITR or I, or sometimes it is J and K also, then these are typically used for your iteration. No rule, but it's like over a period or transition, it came inherently to all the programmers that use IJK for your counters, use standard sum like statements variable names as for your outputs, and then use XYZ or MNPQ are your input. So here you check, ask user to enter a positive integer and then do %d. So this program will keep on running while user either hits a negative number, or it will enter a only negative number. So it will keep on doing this, and as soon as user enters a negative number, this while loop will break, and then it will do summation till all that point. So in this case, even if you put a negative number, this particular program won't get any issues, and then finally you print the sum and return the value. Next is write a program to find a factorial of a number. I don't think we have completed this, but it's very similar to doing a summation addition till continuous natural number ends. The only difference between factorial and the summation program sum of natural number is instead of plus sign you have to use a multiplication sign. So positive factorial of number n is given by n factorial 1 into 2 into up to n. Now, the factorial for negative number doesn't exist, and also factorial for 0 is 1. So these are the two special cases we have to consider before we do this operation. And mostly people will write a perfect code for this and they forget the special case. So in exam, these are the mistakes that students do. We have to avoid these mistakes. So let's understand the factorial program, and then I will ask you to write on your own. So first stdr.h, then main, then you start with fact equal to 1. Then ask user to enter an integer. If he enters negative number, just say error and say factorial of negative number does not exist. Else, for I equal to 1 up to n, just keep on multiplying. And then finally, factorial of percent d is percent LLL. So basically, this factorial, whatever you have calculated. So LLU is long, long unsigned integer, and percent D is for your integer. So most of the time student will get confused, like percent D is for the double, but no, percent LF is for the double and percent D is for the decimal number or a integer, what we better known as integers.
So,
So yeah,
why have you used ULL?
it doesn't matter. You can use percent LF also. So
Okay.
uh, typically the multiplication goes very, very high, and that's why long U is used. But percent LF, or you can declare them as a double also, instead of declaring as unsigned long fact. Like, since I have defined like this way, I have to declare its corresponding number. So if you define as double, it's okay. Now, whatever user numbers like 10, then you get factorial for 10 and this number will be at your output. There is only one condition which was missing, that if user enters 0, but that can be easily satisfied with an if loop, because by default your fact was declared as 1. So since the factorial program number may be very, very large, the factorial variable is declared as unsigned long. That's the only reason. But your double also support 32-bit long length, so which is good enough. 32 bytes, which is 32 into 8 bits, which is good enough. But in case you don't see that is fitting your answer and you are not getting the correct answer, they can use long unsigned value. So basically, it will transfer the remaining half, which was kept reserved in double for negative numbers, also to the positive side. So that is the advantage of using unsigned variable. And long is to make it again 32 byte long. Now, if user enters a negative number, the program will display the error message. Next is program to generate a multiplication table. And this is what we are going to do now. I will stop recording. So if user tells us to say the multiplication table for 5, then you should get 5 into 1, 5 into 2, 5 into 3 automatically. And then you can start writing this code. I will stop recording, and if you have any doubts, you can ask.